the way, I am Jerico Fernandez, and together with my colleague, Garcia, we'll talk about and answer some questions of definite integer. So, example number 1 is x minus x d of x. So, we will say it as the integral or antiderivatives of x minus square root of x all over 3 d of x, where the upper limit is 1 and the lower limit is 0. So first step, we will split the 2. So it will become x all over 3 minus square root of x all over 3, where the upper limit is 1 and the lower limit is 0. So now, we will add plus 1 on the x's exponent. So it will become x raised to 1 plus 1. 1 because x has an invisible number of 1 all over 3 plus, here we will add them, then we got 2 minus square root of x, or simplify it as x raised to 1/2 plus 1 divided by 3 divided by the added number 1/2 plus 1. We got this because of this equation, x raised to n is equal to x raised to n plus 1 over n plus 1, where the n will be substitute as the numbers in the x exponent, 1 and 1/2. So we got this, where the upper limit is 1 and the lower limit is 0. So now we add them, it will become x squared over 3 over 2 minus x raised to 1/2 plus 1 is equal to 3/2. 3/2 because if we use this one as a proper fraction, it will become 2 over 2. 2 over 2 plus 1/2 is equal to 3/2. So x raised to 3/2 divided by 3 divided by 1/2 plus 1 is equal to 3/2. Next, 1 over 0. So next, we will reciprocate this to get 1 over 6 x squared minus 3, okay, 3 and 2, 9, x raised to 3/2. So now we got these two because we know that x's has an reciprocant of 1, so it will become 1/3 times the reciprocal of 2, which is 1/2. So 1/2 times 1/3 is equal to 1 over 6. So we get 1 over 6 here. Next is this. So 1/3 because of this. So times the reciprocal of 3/2 will become 2/3. So is equal to 2 over 9. So here. So now we'll substitute the upper limit and lower limit to x's. So first, we will substitute the upper limit, 1 over 6 times the quantity of 1 squared minus 2 over 9 times 1 raised to 3/2 minus the quantity of 1 over 6. We'll substitute 0 again here, 0 squared minus 2 over 9 times 0 raised to 3/2. So now we will use the calculator to solve this. So now we will calculate this. So 1 over 6 times 1 squared minus 2 over 9 times 1 base 2 3 halves. So it will give us negative 1 all over 18. Next, 1 over 18 minus this. So we will not calculate this because we know that 0 times anything or number will become 0. So here, 0. So negative 1 over 18 minus 0 will become negative 1 over 18. Or negative 0.0555, many 5s, but we'll simplify it as negative 0.06 because we will get the hundreds of it squared units. So this is our final answer, negative 0.06 square units in this equation.
I'm gonna solve example number 2. Our example number 2 is the antiderivatives of 3x squared plus 3x plus 5 dx, where the upper limit is 3 and the lower limit is 1. So we're gonna get the derivatives of 3x squared plus 3x plus 5. I'm gonna write this down as 3x squared. We're gonna plus 1 here, and because we're gonna get the derivatives of the antiderivatives, and we're gonna copy the sum of 2 plus 1 as our denominator is equal to 3 plus 3x. The x has 1 here, so we're gonna add plus 1, so the sum of 1 plus 1 is equal to 2 plus 5x, where the upper limit is 3 and the lower limit is 1. So we're gonna add here 3x cubed all over 3 plus 3x square all over 2 plus 5x. Upper limit 3 and the lower limit is 1. So we're gonna simplify it. We're gonna cancel 3, so the equation will be easier. X cubed plus 3x square all over 2 plus 5x, 3 and 1. We're gonna substitute now the value of the upper limit with x. Replace x with 3 is to 3 plus 3 times 3 square all over 2 plus 5 times 3 minus now we're gonna replace x with the lower limit, 1 cube plus 3 times 1 square all over 2 plus 5 times 1. So we're gonna use our calculator to solve the equation easier. So 3 cube plus 3 times 3 square all over 2 plus 5 times 3 is equal to 111 over 2, and simplify it as in the decimal point 55.5 minus, and the lower limit is 7.5. We're gonna minus it. 55.5 minus 7.5 is equal to 48. 48 square units. And that's our final answer.
So to know your knowledge about definite integral, we'll give you some problems. And here are some problems. Try to solve them at your home. And that's all. Thank you for watching this video.